In this problem, we are given a set of what are called coordinate pairs or a relation. This right here is a relation. And what a relation means is just a set of ordered pairs that are sometimes called coordinates. And you're probably familiar with these. The ordered pairs are given as two numbers. The first number in an ordered pair is called the x coordinate. And this tells us the location of the point in a coordinate plane horizontally, so left and right. So this first ordered pair, 2, 5, means that it will be 2 units to the right. And then the second number is the y coordinate. And the y coordinate tells us the location vertically up and down. And so what we're going to do is we're going to take this relation, and a relation, again, is just a set of ordered pairs. We're going to take this relation and we're going to represent it in three different ways. We're going to represent it as a table, a graph, and a mapping. So let's start with the table. And the table is very simple. A table just means we're going to make two columns, one for the x coordinates and one for the y coordinates. And we're just going to put them in order. So our first ordered pair is 2, 5. So we'll put the 2 in the x column and the 5 in the y column. And then our next ordered pair is negative 2, 3. So negative 2 in the x column and 3 in the y column, like so. Our next ordered pair is 5, negative 2. And our last ordered pair is negative 1, negative 2. And there's our table. Great. So then we're going to do our graph. And so anytime you're graphing, and you've probably done this before, but let's just do a quick refresher. We start at this point right here in the middle, and this point is called the origin. The origin is the coordinate 0, 0. And it's called the origin because that is where we originate. We start at 0, 0, right there in the middle. And so our first point, 2, 5, means from the origin, we count 2 spaces over and then 5 spaces up. And there at 2, 5 is where we put that ordered pair. Then I'm going to go ahead and erase these marks that I made right there. There's 2, 5. Great. Okay, so then we do negative 2, 3 for our next one. So back to negative 2 on the x-axis, 3 on the y-axis, and there is negative 2, 3, like so. Perfect. Okay, 5, negative 2 is going to be over here. If you forgot your quadrants, this is actually in the fourth quadrant. Let's go ahead and label those just for a refresher. This is the first, second, third, and fourth quadrants. And we label the quadrants with Roman numerals so that we don't get them confused with our ordered pairs. And then negative 1, negative 2 is going to be down here in the third quadrant. Negative 1, negative 2. And so now we've done a graph of our relation. Right there, there's our graph. And then the last representation we're going to do is our mapping. And you may not have seen a mapping before. It's very similar to a table in that we have one section for x's and one section for y's. We draw these sort of oval looking shapes. And then in the x oval, we're going to put our x values, which were 2, negative 2, 5, and negative 1. And in the y oval, we're going to put our y coordinates, but our y's are only going to have 3 numbers, 5, 3, and negative 2. And that is because the negative 2 occurs twice, and we only need to write it once in a mapping. And what makes a mapping unique is that the way we indicate which x's and y's go with each other is by drawing arrows. So our first coordinate was 2, 5. So we draw an arrow going from the 2 to the 5. Then negative 2, 3 has an arrow connecting those. And then the 5 goes to negative 2, and so does the negative 1. So we have an arrow going from the 5 to the negative 2, and also from the negative 1 to the negative 2. And that's how you do a mapping. And then the last thing that we're asked to do here is to identify the domain and the range. And a domain, very simply, is the set of all the values in the of the x coordinates. So that was 2, negative 2, 5, and negative 1. There's our domain. And the range is process of elimination, all of the values are y coordinates. And just like with our mapping, we do not write the -2 twice because it only needs to occur one time. It happens two times, but we only write it once in the range. And so there we go. We have taken our relation and we have represented it as a table, a graph, and a mapping, and then we identified the domain and the range.